areas. We will try to see some emerging features of JMP software, but still I didn't have much time to practice. So I will just I will just inform you about my research areas and interests, and how it all started and why I am so much involved in this kind of software approaches, because it's really important. I am dealing with many issues, different issues, as you could see by this session. I think I did a small sample of the problems that we face in statistics. And now let's see a little bit more of connecting these areas. So our schedule will be, I will explain you some motivation to be in these areas. Then some historical notes on the DOE. And why DOE here? First, because it's my main area of research, and second, because it's, I think, the area where we can profit more, even more than the others, of this software. Then I will just talk a little bit about the information sciences and information geometry, and make some considerations and future trends for research. So my main research interests are the DOA, statistical quality control, risk analysis, e-learning methodologies, because our university is totally online, the courses, and our students come from all over the world. And one of my main interests is exploring statistical software so that I can recommend my students the best. That's it. So statistics is renowned for analyzing data and extracting insights from it. Many techniques for data collection, data cleaning, data analysis, and data interpretation have been discussed in literature, in conferences, in meetings, and so on. Statistics is used in fields like business, industry, economics, medicine, social and environmental sciences, in order to understand patterns, trends, and relationships in data. Even in football, people use statistics. If you notice well on TV, each game has the statistics for the players and so on, and for the game's results. So some motivation, some short introduction to DOE and to balanced incomplete block designs and other marked matrices. So it all started in DOE with Sir Ronald Fisher. And there is a very important quote from him that says, it's similar to the opening, to the title of the conference, where we say, we can see that from Stephen Few, that numbers have an important story to tell. They rely on you to give them a voice. And the Sir Ronald Fisher said, let the data speak for itself. So the data, and I think Sir Ronald Fisher didn't yet have the vision of the future that we are living, where data come in so many aspects, like videos, chats, emails, not just simple measures or observations. It comes from simulations. So when he talked about data, this sentence can be used for all kinds of data that we are living now in our reality. So design of experiments aim to extract the maximum information for a given experimental effort, allowing comparisons between varieties or treatments. It focuses on methodologies that allow structuring and designing the conditions and the type and the amount of data involved in an experiment. And what is the aim? The aim is to lead to maximum accuracy in the response, and always seeking to minimize costs. And there are many areas like agriculture, biology, chemistry, and so on, and computer science, where everybody uses DOE. So what were the new contributions from Sir Ronald Fisher? He stated the basic principles of design of experiments like independence, block partition, and randomization, and he was the main responsible for ANOVA. And I show here the model with no formulas, just not to bother you, but to let you know the general idea was that any response comes from a general mean and a factor effect and a component of order. So if you look at the small figure, we have an effect for an action in playing with designs. So what is a balanced incomplete block design? So a balanced incomplete block design has 5 parameters: lambda, b, r, k, nu, b, r, k, and lambda. And a bit with these parameters is a binary incomplete block designs for new varieties that are in B blocks of size k, and such that each variety occurs in R blocks and each pair of varieties appear together or concur. This concur term was first mentioned by Professor Czaliński from Poland, and I like it very much because, in fact, the pairs of varieties concur in exactly lambda blocks. There are the necessary conditions for the existence of a BIP, which are these ones, and we have already stated by Anani some sufficient conditions, but not for general cases. So the association matrix of a BIB design is given by this product and by these results, and there are straight connections from this area to the matricial notation. We can write the incidence matrix like this, and for example, for a BIB design with these parameters, here is the incidence matrix. Why this matter? It matters because and here is an example, an example of a structure of a BIB design with 77331 parameters, and it can be it can look like this. So we have the incidence matrices straightly connected with Hadamard matrices. So the incidence matrix for a BIB design of order n can be obtained through the respective Hadamard matrix of order n equal nu plus 1. So Hadamard matrices are of type H and with entries -1 or 1, so that any distinct 2 rows or columns of H have null inner product. And we have here the Hadamard matrix for the BIB design that I showed. And the DOE design already celebrated 1 century, and I just want to give you an overlook of eras and pioneers for these special methodologies. So it all started with agricultural era in the 20s of last century with Sir Ronald Fisher. Then we have the industrial era 1 in the 50s of last century with the box, and the industrial era 2 in the 70s with the Genishi Taguchi, and we have now from the turn of millennium, the modern era. And there are some papers on the DOE by Richard Deloha from NASA. So what we have now, we assist to a new change and to the beginning of the quantical era, and to future laboratories, which we don't know exactly how they will be in the future. So we have 1 century also of paradigms and methodologies. So we have in the 90s, the paradigm was productivity. then optimization, then quality, robustness, competitivity, innovation, digital information. And in this decade, we attend to the priorities of speed, protection, storage, and globalization. And we will assist soon, I think, in the quantic DOE era. So there are straight connections from this area of design of experiments and from balanced and complex block designs to coding theory, information theory, data science, information geometry, machine learning, data mining, big data, web sciences, media digital arts, e-learning, and many others. So the other matrices have straight connections with coding theory. And I just show you here a very simple example of a QR code, quick response code. This one was from a conference I attended in 2022. And, you know, when we go to the supermarket, all the products, almost all, have these squares for definition. And many announces and many, you know, restaurants already have the menu in this format. But I think people likes to avoid mathematics, likes to avoid, you know, calculations, like to avoid, they don't know matrices and so on, but they are in their daily life. If they like it or not, they use it, and they use it even from NASA to send us information about other planets, about photos from Mars, and so on. So it is really an emerging area, very, very, very important. So there are some technical changes that we assist to. It's very important to study information geometry and computations. So because we have information geometry introducing complex and multi-dimensional models, understanding and optimizing these models requires advanced computational methods and a deep theoretical approach. So that's where our software that we are announcing in this workshop can make a key role. So the computational resources needed for these integrated systems are significant, involving extensive processing power and specialized hardware. Challenges in scalability and real-time application due to increased computational requirements. So we also have the need of having data and algorithmic transparency. So we need high quality, extensive data sets, which are crucial for the effectiveness of these models, posing ethical and practical challenges in data acquisition. So as models become more complex, maintaining algorithmic transparency and interpretability is critical. And we have the rise of big data also with several V most quotes. I mean, volume, value, veracity, visualization, variety, velocity, totality, and so on. And with the rise of big data and the increasing importance of data-driven decision making in various industries and various scientific fields, the borders integration of statistics, information geometry, and computation methodologies are becoming crucial. So the combination of these disciplines allows for a more accurate and robust analysis of data, leading to more reliable results and actionable insights. So many techniques for data collection and so on have been discussed, and statistics is used in almost all the fields. So when new ideas are coming into this world, somewhat like falling meteors with a flash and an explosion, and perhaps somebody's castle roof perforated. This was said by Henry David Thoreau, and these new ideas also are still coming and facing challenges, as we can see now, adopting JMP and choosing it as one of the best softwares for statistics. So information sciences are very important. Why? Because it takes information as tools, algorithm complexity and maximum entropy. And we have many, many applications, as we can see in this schema. And now visualization also is a cornerstone of statistics and data science. And learning how to visualize the data before applying more sophisticated methods is a hallmark of data scientists. So we have, for example, these links where you can study more about this, but visualization is one of, and flexibility are one of the main issues that makes the difference in our software JMP. So I'm giving you here some computational issues like software that we are used to teach in our classes. We used to have Python, we used to have R, more recently Julia, 2 years ago or something, it started to be the hot software. We have JAMOV, and now we have the JMP, which you can read much more if you download this link with materials. So what are the highlights? The main highlights of JMP, and you are maybe already tired of hearing so much advantages of this software, but visualization and the fact that it is interactive and in statistics are really very, very important. So I think I saw in a JMP academic program that the engine of innovation is the ability to derive valuable insights from data, and used at more than 1,300 colleges and universities by thousands of professors and hundreds of thousands of students. It is helping to build the data literacy foundation of the next generation of scientists and engineers, and providing industries around the globe access to earlier career professionals with skills in data analytics. And you can read more in this link. The hopeful. I saw this text by Al Varian, a Google's chief economist, and he said something very, very similar. That is the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it. That's going to be a hugely important skill in the next decades, not only at the professional level, but even at the educational level for elementary school kids, for high school kids, for college kids, because now we really do have essentially free and ubiquitous data. So the complementary scarce factor is the ability to understand that data and extract value from it, because not all data matters, but we have to have tools to extract the useful information from data. And that's why it is so much important, the information geometry for in our studies. As a personal goal, I want to share with my students all the tools so that they can be able to think critically about data and analyze them in several ways. Because data does not necessarily gives you information. Information is different of knowledge, and knowledge without context is not necessary, meaningful, or useful. So just for us to reflect a little bit on how far these have been going from last century to this one, we can just see that the main issue was oil in the last century. Look that, for example, transports were like this, and look at the difference and the materials built in series, and man getting to the moon. And in this century, we assist to a digital way of looking, and the data are the oil of this century, definitely. So now we can move by plane, by and visit some planets with, with NASA. So now we are very close to the artificial intelligence robotic overcoming in the world. And thank you so much. And if you have any questions, please